student, welcome to my channel. So in this slot, we're going to discuss Ramalan SPM 2021-2022. Okay, let me start with a revision for all Form 4 topics. So stay focused. Let me start with all the important definition. The first definition that student must remember the meaning of chemistry. Chemistry is the word originated from Arabic word known as alchemia. It's a study about four things. Number one, structure, properties, composition, interaction between matter. All right, so the second definition that student must remember what is the meaning of the isotope. Okay, isotope are atoms of same element, so atoms of same element which show same proton number but different nuclear number. Or student can write in another way, which is atoms of same element which show same proton number but different, same number of protons, different number of neutrons. All right, so we check the third definition. What is mean by RAM? What is mean by RAM? Relative average mass of an atom when compared with 1/12 times mass of carbon 1 carbon 12 atom. All right, so we go for fourth definition. What is mean by 1 mole? Quantity of substance that contains as many particles as in exactly 12 gram of carbon 12, which is exactly the Avogadro constant. All right, we go for the most important definition, which is known as empirical formula. So the meaning of empirical formula is known as chemical. So I put here chemical formula. So try to put chemical formula that shows the simplest ratio of all number of atoms of each elements that present in a compound. All right, we go for what is mean by period and what is mean by horizontal. Period is known as horizontal row of element in the periodic table, and group stand for vertical column of element in the periodic table. And remember, the period stand for one number of shells, and the group stand for what? The number of valence electron. All right, we go for seventh definition, the meaning of strong acid. Strong acid, an acid that ionizes completely in water, producing high concentration of hydrogen ion. Okay, and the ions that responsible for the showing the acidic properties, remember hydrogen ion or hydroxonium ion. All right, so remember all the strong acid and their formula. The strong acid and their formula very important. Number one, hydrochloric acid. Number two, sulfuric acid. Number three, nitric acid. These are the three strong acid the students must remember. All right, we go for eight definition. Number eight, rate of reaction. So the meaning of rate of reaction, general definition. This will be general definition. Later we will go for the specific definition. The change in quantity of reactants or product per unit time taken. Right. Then must remember the next one under rate of reaction, catalyst. Catalyst is a chemical substance that added in small quantity in a chemical reaction to alter the rate of reaction. Okay, without itself involved in the reaction. All right. So the meaning of composite material, the new substance that produced from the combining of two or more non-homogeneous substance, that is matrix substance, and strengthening the substance together. All right, so this will be this is Form 5 definition. I will be covered in our next slot. Today we will just go through all the Form 4 topics. All right, I move on to the next one, the important definition. This is Form 5 topics. So I go for move to next important chemical equation that students must remember. The first one is empirical. Magnesium react with oxygen. So magnesium react with oxygen. The equation is given here. Student can write another one. Zinc react with oxygen. To determine the empirical formula of reactive metal, so I'll take a zinc react with oxygen, so we will get zinc oxide. Balance the equation. Remember the equation, the formula should be correct, and we should balance the equation. So how to balance this equation? Check oxygen 2, here oxygen 1, so I balance by adding 2 in front of zinc oxide, and we need to balance the zinc 2 here. All right, next one, to determine the empirical formula of less reactive metal, this equation, copper 2 oxide. Copper 2 oxide reacted with dry hydrogen, we will get copper and water. Student can try another one. Lead 2 oxide react with dry hydrogen. Lead 2 oxide react with dry hydrogen, we will get lead plus water. All right, lead plus water, and this equation balance or not? Is balanced. All right, sometimes the actual symbol they in the question they won't give the actual symbol, they will give the symbol that not represent the actual symbol. For example, check question number 3, group 1 metal. Okay, group 1 metal react with water. So react with water, group 1 metal. So we check what are the group 1 metal. Group 1 metal is known as alkali metal. Group 1 metal is known as alkali metal. This group 1 metal is known as LiNaC, lithium, sodium, and potassium. They will form lithium positive, sodium positive, potassium positive. If, for example, let's say in the exam they give us sodium react with water. So how to get the product? Take out the Na positive, hydrogen ion and take out the hydroxide ion. During chemical reaction, sodium ion join with hydroxide ion, so we will get sodium hydroxide, and erase this one. So when hydrogen ion single covalent, so you put here hydrogen gas. Balance the equation. How to balance the equation? Check hydrogen here 3, here 2. Make it even number, so I times 2 here, so hydrogen become 2 plus 2 hydrogen 4. So here I times 2 hydrogen 4. Then I balance the sodium 2, so sodium 2. The equation is balanced. So sometimes they won't give the actual symbol, they will give a symbol like X react with water. So remember this element from group 1, it will form X positive. So take out the ion hydrogen ion, hydroxide ion. During chemical reaction, combine XOH. When we see hydrogen ion single covalent, so make sure hydrogen gas. How to balance the equation? Check the number of hydrogen atom. Okay, 3, so make it even number, so make it 4. So then X is 2, X is 2. Okay, hydrogen here total 2 plus 2 4, so hydrogen 2 times 2 4. So that's the one I wrote here. All right, so next one, remember group 17 element. Group 17 element is known as what? Group 17 element is known as halogen. So under group 17 we have fluorine, chlorine, bromine, okay, bromine and iodine. They exist as diatomic molecule. Okay, diatomic molecule. This group 17 halogen can react with iron wool, can react with water, and also can react with sodium hydroxide. So I'll take one example. Iron react with chlorine. So remember iron, we have two type of oxidation number. One is Fe2 positive, another one Fe3 positive. Please take iron 3 ion in this reaction. So I take Fe3 positive, chloride ion combined together, so we will get FeCl3. The name of the compound form is iron 3 chloride, and the color will be brown color powder. How to balance the equation? You got 2, you got 3, so what I do, 2 times 3 6, 3 times 2 6, iron 2, iron 2. This is the first reaction, halogen react with iron. All right, so we go for next one. So you already wrote this one. Okay, Ethernovic acid. Remember one more acid. Ethernovic acid is an organic acid, so I'll write down here. So Ethernovic acid. The formula of Ethernovic acid, CH3COOH. It will ionize partially in water, and the hydrogen ion at the behind one will break. It will produce ethernovic ion plus hydrogen ion. So when ethernovic acid react with sodium hydroxide, NaOH, what we will get here? Take out the ion CH3COO negative and hydrogen ion from here. All right, so here we take out the sodium ion and hydroxide ion. During chemical reaction, hydrogen ion and hydroxide ion combine will produce water molecule. This sodium ion will combine at the behind of the oxide ion. So here CH3COO, and we check here charge value 1 1, so no need to do bracket. All right, so this is the one we do here. I do here. All right, so next one, carboxylic hydrochloric acid react with marble. Chemical name for marble, please remember calcium carbonate, and the symbol will be CaCO3. The equation is given. Okay, react sodium react with oxygen. Sodium react with oxygen. Sodium metal Na react with oxygen. Please remember we will get a sodium oxide. When we take this sodium oxide Na2O dissolve in the water, what product we will get? Remember, during writing chemical equation, A plus B will get C plus D. When A plus B, the B is keep on repeating here. Please erase the B. So I try to do this equation together with y'all. Okay, those having this module, please try. Okay, sodium ion, oxide ion, hydrogen ion, hydroxide ion. During chemical reaction, this and this join, so we will get sodium hydroxide. Hydrogen ion join with hydroxide ion, we will get water. So erase this one. We try to check A plus B. So this B is repeating here, so erase this one. So next, balance the equation. Sodium 2, so I put here sodium 2. The equation is balanced. So check this one and also this one. Next one, question or equation number 8, halogen react with water. Something very special. So in this reaction, we will get acid plus hypochlorous acid, and this acid is known as what acid? We call strong bleaching agent. This is known as strong bleaching agent. So in this reaction, if they ask observation, so blue color litmus paper will turn to red and then bleach. All right, so we try to check how to do this one. I do another example here. All right, so I do another example. Bromine react with water. So what product we will get? Take out bromine atom, water we break like this. This group 17 is group Palaskate. So what you do? HO. Okay, during chemical reaction, H join with Br, so we will get HBr. This Br join behind here, so we will get HOBr, hypobromous acid. So this one observation blue litmus paper will turn to red and bleach. All right. So we go for our next reaction. Okay, copper to carbonate when heated strongly. Remember this word form equation must memorize metal when metal carbonate heated strongly. So we will get metal oxide plus carbon dioxide. So when copper to carbonate, which is green color stone or green color powder, is heated, we will get the metal present here is copper. Okay, the metal that present here copper, the metal ion that present here is copper to ion. So change here with this one, so we will get copper to oxide plus carbon dioxide. All right, so we go for next one is metal nitrate. When metal nitrate heated strongly, so there's a two type of salt that can undergo decomposition, so thermal decomposition. The next salt is known as metal nitrate. When metal nitrate heated strongly, we will get metal oxide plus brown color gas, which is nitrogen dioxide plus colorless gas. Okay, during this reaction, so I take one example here. So this example I already given to you all, so go through the module. I check another, we do another example. So I don't know this one how to do, so we try to check together. Copper to nitrate. When we take copper to nitrate heated strongly, we will get how many product? The metal that used here is copper to ion. So the product will be copper to oxide, nitrogen dioxide, and oxygen. How to balance this equation? Just put 2 here, copper 2, nitrogen 2 times 2, 4, nitrogen 4. Oxygen balance itself. Oxygen 6 times 2, 12, oxygen 2, 8, 12. All right. Okay, we go for our next one. Zinc powder added with hydrochloric acid, we will get salt plus hydrogen gas. So we try to do another one. Please remember this one. Wajib ingat, hydrochloric acid react with copper. What product we will get? So the answer will be no reaction. Why no reaction? Because copper is less reactive metal. All right, so next will be under decomposition of hydrogen peroxide. When hydrogen peroxide decomposes, it will produce oxygen and water molecule. Next under will be sodium thiosulfate. Remember, we have unstable compound. Okay, when we get unstable compound like this, okay, thiosulfonic acid, it will rearrange to give you sulfur dioxide, and water. Yellow color precipitate will form. When we take hydrochloric acid, react with sodium thiosulfate. Please remember, take out the hydrogen ion, take out the chloride ion, take out the sodium ion, take out the thiosulfate ion, S2O3 2 negative. During chemical reaction, this and this join, so we will get sodium chloride, and H join with thiosulfate hydrogen ion. When joined with thiosulfate ion, we will get unstable compound, which is thiosulfonic acid. Okay, this thiosulfonic acid will rearrange itself, produce sulfur dioxide, sulfur, and water molecule. Take the sulfur, put here, sulfur dioxide and water. We will get 4 product. Okay, and balance the equation. The students must remember how to must know how to balance the equation. So I balance sodium 2, so here I put 2. So then you check chloride 2, the rest is balanced. So state the observation, yellow color precipitate is formed. All right, so we go for our next reaction. Okay, next reaction, magnesium react with copper to sulfate. This is known as displacement reaction. When we take more electropositive metal reacted with added in salt solution that contains less electropositive metal, displacement reaction will occur. We check another example. If I take zinc react with silver nitrate solution, so what product we will get? We take out the ion. Zinc is more electropositive metal. It will oxidize to form zinc 2 positive ion, and silver ion less electropositive metal. So we have nitrate ion. The nitrate ion will not involve in the reaction. So during chemical reaction, which one is more electropositive? This one. So combine together. Zinc will combine together with nitrate ion. So zinc nitrate ion. So I take the charge 2, I put here. So we need to do what? We need to open bracket. So I put zinc nitrate plus what will happen to the zinc? Erase the charge, put here. So how to balance the equation? We need to balance the nitrate. Whole thing I times with 2 here. So where is nitrate? Everything you times with 2. Then silver 2, silver 2. What is the observation in this experiment? Please check which is the metal is deposited, and please remember all solid metal. Okay, metal are gray color solid except copper, which is brown color. So in this case, we will get shiny gray, solid deposited. Right, so please check all these equation. Okay, and next equation please go through is under double decomposition or precipitation reaction, where we will get a insoluble salt which is led to iodine. This is insoluble salt, it will form yellow color precipitate, and this reaction is displacement of halogen. So I will go through this one during when I do revision for form 5 chapter. All right, so these are half equation we will discuss in form 5 chapter when we learn form 5 topics. All right, so we go for move on to the next one. Try to remember how to do formula and also name the compound that form. If ammonium carbonate is given here, NH4CO3 2 negative, try to get the formula. Remember, polyion when crossing must put bracket if let's say 2 or more. Okay, so I do here ammonium ion, carbonate ion. During chemical reaction, NH4CO3 will get here. So how to do the formula? These two will go here. Okay, and here we have one. One will go here. Remember, one no need to do bracket. So where you have to do the bracket here lah. So you have to do bracket in front of the ammonium ion. So I do the bracket, I put the 2, then carbonate. So we will get the formula. We try to do next one, lead to nitrate, lead to ion, Pb2 positive nitrate ion. During chemical reaction, how to do the equation PbNO3. So when this is 2, the 2 goes here. Okay, the 2 goes here. So we need to do bracket. Why? Because this is known as polyion. Polyion when 2 or more, when we crossing, when we get 2 or more, we must do bracket. Alright, so this is the equation formula. Chemical ion symbol for magnesium ion, symbol for chloride ion. Try to get the formula here. Sometimes they give the formula, they ask the name. Please remember these 3 ion. Remember copper 2 ion. Copper 2 ion. This ion is, we need to mention the oxidation number, copper 2 ion. Okay, Cu1 positive is known as copper 1 ion. All right, so next one, Fe2 positive is known as iron, iron 2 ion. Fe3 positive is known as iron 3 ion. All right, so next one, we must remember last one, this is known as lead 2 ion. All right, so when we get this type of compound, copper 2 oxide, lead 2 oxide, iron 2 sulfate is a green color solution. All right, so we go for next one. So we move on to the all the important particles and the example formula of ions and the arrangement of particle physical state and the kinetic theory of matter. So particles can be divided into 3. Number 1 is known as A, stand for atom. A stand for atom, molecule, and ions. So check all the atoms. The atoms can be made up of single unit smallest particles that cannot divide it anymore. How to identify one capital, one small? One capital, one small is atom. One capital, one capital, one capital, one capital. All this is atom. Okay, and most of the atoms exist as solid state. Most of the atoms exist in solid state. How to draw the arrangement of the atoms? The arrangement of atoms are arranged in order and closely packed. All right, these atoms do not move. They only vibrate and rotate at the fixed position. Next, we check on the molecule. Molecules are made up of non-metal plus non-metal. They are made up from covalent compound. Please remember 5 non-metal atoms, which is carbon, hydrogen, oxygen, nitrogen, and sulfur. Carbon, hydrogen, nitrogen, oxygen, and sulfur atom. When non-metal combine, the type of particles is molecule. The type of bonding is known as covalent bond. All right, so we try to check few example of molecules. So molecules are made up of non-metal. Please remember 5 non-metal. So we try to check nitrogen gas molecule, naphthalene C8H10 or C10H8 will be molecule. Okay, if in the exam they ask what is the formula of sulfur phosphorus molecule, that will be P4. Sulfur molecule will be S8. All right, so ammonia, ethanol, and glucose. Most of the molecules, they exist as gas, so the arrangement of the particles will be further apart from each other. All right, so, and the movement of the particles that exist as a physical state in gas is moved randomly and collide each other. Next will be ion. Ion are made up of metal plus non-metal. So when we have metal plus non-metal, metal plus non-metal, they are made up of ion. Ion exists as ionic compound. So we have few example of a metal ion. So metal ion: king, netto, catch, mango. Mango, after Zaret, fly. Fly, Singapore. Singapore, purchase. Purchase, Hawaiian is not metal. Cute, amoy. These are the metal. Kalau nak kahwin mesti ada zakat fantastik supaya papa cucu anak. All this metal. When this metal ion combine with non-metal ion, they are made up of what particles? Ion. And they are made up of what type of bonding we call ionic bonding. So student must remember all this. Most of the metal ions exist as liquid. So the arrangement of the particles in liquid will be like this. They are closely packed but not in order. They move throughout the liquid. So we try to check the kinetic theory of matter. When the smell of fried chicken spread from the kitchen to the living hall is known as process is known as diffusion. And the fried chicken gas smell, okay, is made up of, when gas is made up of molecules, they can spread and occupy the empty space that present between the air molecule. The air molecules, there's a lot of empty space when they move from the region of high concentration to the region of lower concentration. Diffusion process occur. So look at the question. The smell of the fried chicken spread from the kitchen to the living hall. Based on the kinetic theory of matter, explain the process. So how to explain this one? The fried chicken smell. The fried chicken smell is a matter made up of tiny and discrete particles. The fried chicken gas smell move. They are exist in gas, so we must put move randomly. They move randomly and occupies the empty space between the air molecule. The fried gas smell or fried chicken gas move from the region of high concentration to the region of lower concentration. That's how we explain for the diffusion process. Now we move on to all the formula of ions. Okay, and we try to check which ion is colored ion, which ion is colorless ion. So king, potassium ion K positive, sodium ion Na positive, calcium ion Ca2 positive, Mg2 positive will be magnesium ion, Al3 positive will be aluminium ion, zinc ion Zn2 positive, Fe2 positive will be iron 2 ion, and we have another one Fe3 positive, which is iron 3 ion. Tin ion or sternum ion will be Sn2 positive, lead 2 ion Pb2 positive, hydrogen ion, copper 2 ion, silver ion Ag positive, ammonium ion. Among all these ions, all these ions, copper 2 ion will be blue color ion, iron 3 ion will be brown color ion, and iron 2 ion will be green color ion. The rest will be colorless ion. Student must remember. We move on to the N ion. So before we move on to the N ion, if in the exam they ask what is mean by cation is known as positively charged ions or positively charged particles. We move on to the N ion. N ion is known as negatively charged ions or negatively charged particles. So these negatively charged particles or ion, we have few ions that student must remember. Number one will be fluoride ion F negative, sulfate ion SO4 2 negative, nitrate ion NO3 negative, chloride ion Cl negative, carbonate ion CO3 2 negative, bromide ion Br negative, I negative, oxide ion O2 negative, hydroxide ion OH negative, thiosulfate ion will be S2O3 2 negative, manganate 7 ion MnO4 negative, dichromate 6 ion Cr2O7 2 negative. All ion N ion are colorless ion except these two ion MnO4 negative, which is purple color ion, and Cr2O7 2 negative. Remember the O, it stands for what color? Orange color ion. Alright, so these are the formula of ions that student must remember before you take SPM. Next, we move on to all the uses from Form 4, first chapter until chapter 8. Alright, so number one, I'll start with isotope. Isotope, atoms of same element which shows same proton number but different different nucleon number, or same number of protons but different number of neutron. So we have few isotope and their uses that student must remember. Number one, carbon 14 to determine the age of fossil. This is very important for SPM. Okay, please remember. Phosphorus 32 to study the rate of absorption of fertilizer by plant or to study the plant metabolism. Second one is sodium 24 to determine the underground pipe leakage. Hydrogen 3 as a detector to study the sewage or liquid waste. Lead 210 to study the age of sand and earth layer up to 80 years. Uranium 235 is used in a nuclear generator nuclear generator to generate electricity. Next will be carbonate, group 718. Group 718 is known as noble gases or inert gases. This group 18 element, we have few group 18 element. So how to remember all these? Need a ni X-ray. So E stand for helium, neon, argon, krypton, xenon, and radon. So among all these, the very important one is krypton. Krypton is used in LASIK treatment to repair the retina. Neon is used in advertising billboard. Radon is used to destroy cancer cell. All right, so we move on to the next one, methanoic acid. The formula of methanoic acid, HCOOH, is a weak acid, is used in coagulation of latex to turn the latex in liquid form into solid form. Ammonia, the formula of ammonia, NH3. This ammonia exists as molecules is used to prevent the coagulation of latex. It will maintain the latex in liquid form. It's also used to make fertilizer, act as cooling agent in refrigerator. Next will be sulfuric acid. The formula of sulfuric acid will be H2SO4. The sulfuric acid is a strong acid, is used to make fertilizer, detergent, and paint. All right, we move on to the alloy. Alloy is a mixture of two or more elements with certain fixed composition in which the major element will be metal. The major element that present in front should be metal. Okay, so we have X plus Y. So this X should be metal, and this metal present in main component composition. Major component is a metal ion or metal atom, and this alloy exists as atoms, not ion. Sorry. So we have few alloys that student must remember. Number one, steel. Steel is made up of iron plus carbon. If in the exam they ask us what is the composition of stainless steel, so we take this iron plus carbon. We take this one, add chromium. Okay, chromium stand for Cr. So that is stainless steel. Okay, so the function of steel to make building, bridge, railway track. And stainless steel is used to make cutleries, surgical instrument, automobile parts. And next one, bronze and brass. Please remember bronze and brass. So I put here bronze. Okay, here I put brass. The major component or major atoms that present is copper. The minor component will be, remember the Z, remember N. So the Z make it Zn, zinc, and S make it Sn. So switch the place. So here will be Sn. This will be zinc. So this is the composition of bronze and brass. So here will be bronze made up of copper and tin. Brass is made up of copper and zinc. Okay, to study bronze is used to make national monuments, decorative, trophy, medals, all that. Brass is used to make musical instrument, key, nut, bowls, doorknob, all that. All right, so this polymer is under form 5. I will try to do in another slot. All right, we move on to the next one, glass. We have 4 type of glass. If in the exam they ask what is the main component or raw material that used to make glass, is silicon dioxide. Okay, main component that used to make glass is silicon dioxide. Glass is transparent, easy to clean, hard but brittle. So we have few glasses that student must remember. The glass that made up of only silicon dioxide is used in laboratory to make a laboratory glassware. Okay, that will be fused glass. Okay, another glass that used to make laboratory glassware, and this glass can withstand high temperature, that glass will be borosilicate glass. Okay, if let's say in the exam they give this one, a glass that used to cook food, okay, can withstand the temperature, this is glass, so the name of the glass will be borosilicate glass. All right. Okay, please study lead glass also. Okay, it's used to make a decorative glass. All right, with high refractive index. All right, so next one, advanced ceramic. Okay, advanced ceramic is used to make a heat shield for rocket. Okay, that will be heat insulator. Another ceramic that used to make to reduce the emission of toxic air pollutant in the exhaust pipe will be catalyst converter, that will be alumina. Electroceramic contains silicon carbide. Is used to make capacitor, magnetic sensor, all that. Okay, zirconia ceramic is used to make knife, orthopedic, mortar, pestle. All right, so next one will be composite material. Among all these composite material, the very important one is photochromic glass. Photochromic glass is used to make sunglasses, car window, car tinted, even building. Even we can use building glass window. Okay, glass window is used on it. It has it can darken during daytime and become brighter during nighttime, depends on the intensity of UV light, and the substance that present is glass, and another substance very sensitive to UV light, silver chloride or silver bromide. Superconductor, yttrium oxide, sodium carbonate, copper 2 carbonate, and even oxygen is used in the electrical system in bullet train, MRI machine. Is conduct electricity with zero resistance. Reinforced concrete is used to make high rising building. It has concrete and steel bar. Optical fiber, it has glass, fluoride glass, phosphate glass, and plastic. Okay, it can transmit the data with the speed of light. Is used in computer network, tube for endoscope, even LAN cable, local area network cable. All right, so we move on to this one. This one is under form 5, so I will try to do this in the another slot. All right, thermochemistry will be under form 5, so I will do in another class slot. All this is under form 5, so I will do in another slot. All right, so we move on to the first chapter. This year I'm expecting chapter 1, introduction to chemistry, will come out in your SPM. Okay, the first thing that student must remember, the contribution of chemist. The chemist that introduced scientific method will be Robert Boyle. Antoine, remember, is one of the founder of modern chemistry. He introduced the law of conservation of mass and theory of combustion. Self-protecting equipment, laboratory coat. What is the function? Is protect the body and clothes from chemical spill. Glove, okay, is protect the hands from injuries, chemical infection, all that. All right, so next one will be chemical spill. Okay, suggest emergency management and procedure in the laboratory. Okay, acidic spill. Wash the spill with a lot of water and channel it into the drainage system. Okay, neutralize the spill area by using sodium carbonate solid or solution to wash and then wash with water. Mercury spill. Okay, mercury spill is very important. So what are the emergency management procedure that student must know? Okay, first thing, open the window and door to allow sufficient air. Second thing is what, make the area spill area as prohibited area. Third things is what, four things, we sprinkle with sulfur or zinc powder, okay, to cover up the spill. And third one, contact the fire and rescue department for further action. Please study on the cloth on fire. Wrap the victim with the fire blanket and roll on the fire blanket. Seek medical treatment. All right, so we move on to the next one. Suggest a storage method of following chemicals. So we have few, so I'll take the important one, reactive metal. What are the reactive metal? The reactive metal can be potassium, sodium, calcium. All this is a reactive metal. To prevent reaction with water and oxygen, we must keep in paraffin oil. Substance that easily decompose like chloroform, ammonia, all that should be kept in the dark bottle to avoid contact with light and heat sources. And suggest a disposable method of chemical waste after an experiment is used. Hydrogen peroxide, H2O2, is a chemical substance with low concentration. We can pour directly into sink. If it is high concentration, the hydrogen peroxide has to be diluted with water, added with sodium sulfate before it being poured into a sink. A substance with pH value less than 5 or more than 5 is considered as concentrated acid or alkali, concentrated acid and alkali. And these substances are very strong acid and alkali, can damage the sink if we directly pour into the sink. Okay, and it also can react with water to produce high heat and toxic, should be kept in closed label container. The substance that can easily volatile like alcohol, ammonia, bromine, chloroform, all hazardous and can fatal if inhaled in large amount. It should be closed, stored in closed container and keep away from heat and light sources. The organic solvent and hydrocarbons. Okay, organic solvent and hydrocarbons are toxic, volatile, toxic and carcinogenic. Volatile and inflammable, cannot be poured directly into sink because it causes what, water pollution. So should be kept in special container made up of glass or plastic. All right, so we move on to the second chapter. In chapter 2, we matter and atomic structure. The important things that student must remember: what is mean by melting point. The meaning of melting point is known as temperature at which solid is changed into liquid at certain condition or certain pressure. The next definition that student must remember: what is mean by nuclear number. When we have sodium 23, okay, 11. So this large number 23 is stand for nuclear number. Nuclear number is stand for P plus N that present in the nucleus of an atom. Total number of protons and neutrons that present in the nucleus of an atom. So next one, the melting process of naphthalene. Naphthalene exists as molecule because it has non-metal plus non-metal. So the first point, state the type of particles present in naphthalene will be molecule. All right, so when we check this graph is a heating process of naphthalene melting process where solid is changed into liquid. The particle here will be in solid, here will be at liquid state, and here mixture of solid plus liquid. All right, so what is mean by melting point? Temperature at which solid is changed into liquid. Explain why the temperature remain unchanged from T1 to T2, because heat energy is absorbed to overcome the forces of attraction between the particles. So the heat energy is absorbed by the particles, is used to overcome the forces of attraction between the particles so that the solid can turn into liquid. So next will be determine the melting point. Where is the melting point? When the particle in the state of liquid and solid and liquid, that will be the melting point. So the melting point is a temperature at which solid change into liquid. So 78.0 degrees Celsius. State the physical state of naphthalene at melting point, which is 78 degrees Celsius, will be mixture of solid and liquid. Okay, and what is the purpose of using water bath in this experiment? So it ensure uniform heating process, and furthermore naphthalene is flammable. Okay, I'll try to look at the question. Sodium nitrate has a melting point of 300 degrees Celsius, and can the melting point of sodium nitrate can be determined by using water bath? Explain your answer. So in this diagram I put water. The boiling point of water will be 100 degrees Celsius, and the melting point of sodium nitrate will be 308. So what will happen when the temperature reach 100 degrees Celsius? The water will turn into gas. There is no more water, so we cannot use water bath. Instead of this, we can use oil bath. Certain oil, it has a boiling point of 400 degrees Celsius. So answer will be no, cannot. The melting point of sodium nitrate is higher than the boiling point of the water, which is 100. We can use oil bath to replace the water bath. Okay, try to check the temperature on it. Why the temperature remain unchanged during freezing process? During freezing process, so here will be temperature, here will be time. The graph shape will be like this. It will go down. Why the temperature remain unchanged? Because the heat energy released by the particles is exactly, must put released by the particles is exactly balanced by the heat loss to the surrounding as the particle attracted to one another to form a solid. All right, so we go for three main subatomic particles. What is the main subatomic particles that are present in the atom? PEN. P stand for proton, and E stand for electron, and N stand for neutron. So the answer is given here. Please study and please remember. All right, we move on to the next part. State the name of the person that introduced proton, electron, neutron, the three subatomic particle as well as shell. Proton is introduced by Ernest Rutherford. Electron is introduced by J.J. Thomson. Neutron is introduced by James Chadwick. Shell is introduced by Niels Bohr. If in the exam they mention like this, here we have proton and neutron. All right, so orbiting the nucleus in the shell, okay, is electron, and they mention here neutron. So neutron, who's the one introduced neutron? The answer will be James Chadwick. We move on to the next type of question. The table given in the table, number of protons and number of neutron is given. Try to highlight this one, number of protons, number of neutron. If number of protons same, the atoms with number of protons same, which is this one and this one, and number of neutrons is different, that will be isotope. So here isotope W and Y. So which atoms are isotope? Atom W and atom Y. Explain your answer, because atom W and atom Y has same number of protons, different number of neutrons. All right, so use the terms given in the table. All right, write the electron arrangement of atom X. So I put here X, it has proton 7. So 7 will be 2.5. So the answer will be 2.5. All right, this 2.5, that means it belongs to group what? Group 15. Don't put group 5, group 15. And it belongs to period. How many numbers present here? 1 and 2. It's from period 2. All right, so next they ask us to draw the electron arrangement of atom Y. Draw the electron arrangement of atom Y. So atom Y is here. It has 16 proton number, and nuclear number will be 16. Proton plus neutron, 16 plus 16 will be 32. So total proton will be 16, total electron. This atom is neutral. When neutral, proton equal as electron, so 16, so neutron will be proton. 16, 32 minus 16, that will be 16. So how to draw draw the electron? Write the electron arrangement 2.8.6. In the nucleus it has 16 proton plus 16 neutron. So label the nucleus 16 proton and 16 neutron, and try to draw 3 shells and fill up with the electron as shown here. Sometimes they ask us to give draw the electron arrangement of ion. So for example, let's say I take X. Okay, they ask us to draw the electron arrangement of ion X. How to draw this one? So we try to do atom X has proton number of 7. Do the electron arrangement 2.5. Check the valence electron. When valence electron, always remember valence electron 4, 5, 6, 7, they are belongs to non-metal. Non-metal will form N ion. What is N ion? Is a negative ion. Negatively charged particles. Is a negatively charged particle. How they form? They accept electron to achieve what? To achieve stable octet or stable electron arrangement. In this case, it needs 3 more electron to achieve stable octet electron arrangement. So N ion, take the negative, put here. It need how many electron? Check the valence electron 5. It will accept 3 electron to achieve stable octet electron arrangement. Take the 3, put in front here. And this is the formula of ion. How to draw the electron arrangement of this ion? Write the electron arrangement of this ion 2.5. It gain 3 electron or accept 3 electron and form 2.8. So how to draw? Open bracket, put the X. Okay, put the charge value 3 negative, and how many shell? 2 shell. First shell, second shell. Okay, first shell and second shell. First shell, it has 2 electron. Second valence shell, it has 5. It accept 3 electron. It accept how many electron? 3 electrons. So put here 1, 2, 3. This is the drawing for the ion X. All right, so we move on to the next part, chapter 3. Under chapter 3, the mole concept, chemical equation, and formula. So this under here, there is a one definition that student must remember also. And empirical formula, the next one will be molecular formula. What is mean by molecular formula? The formula that shows actual number of atoms of each element that present in a molecule that form a compound. Okay, why magnesium oxide? What does the method to determine the empirical formula of copper 2 oxide? Copper 2 oxide, okay, we use combustion tube method. For magnesium oxide, we use crucible method. All right, so why we cannot use this one for magnesium oxide? Because magnesium is reactive than hydrogen. Hydrogen gas cannot reduce magnesium oxide to magnesium. All right, this is stoichiometric calculation, 100 cm power 3. Okay, 100 cm power 3 is stand for volume, and 1.0 mole dm negative 3, this is stand for molarity. All right, so when we have m and v, try to check mv over 1000 to determine the number of mole, and unit will be mole. All right, so first thing they ask us to write the chemical equation. Sulfuric acid H2SO4 reacted with sodium carbonate Na2CO3. So the equation will be like this. Balance the equation. All right, so equation I already score 2 marks. Use the number given here, convert into number of mole by using this formula, mv over 1000. So I apply, I got 0.1 mole. Then find the ratio molarity. Check the question. They want calculate or what is the volume of gas carbon dioxide. We have sulfuric acid. They want carbon dioxide. So here 1 mole give us 1 mole. So write down in the equation ratio. 1 mole of sulfuric acid give us 1 mole of carbon dioxide. Take this mole, put here 0.1 mole of sulfuric acid will give us same 0.1 mole of carbon dioxide. When we have number of mole, how to find volume? So we have number of mole, volume over molar volume. From here, rearrange the formula to find the volume. How to rearrange the formula? Volume stand for what? Number of mole times with molar volume. Use this formula to calculate the volume. So this is the answer. The answer is 2.24 dm power 3. All right, next one. Sometimes they give the formula. They ask us to find the relative atomic mass, and given to us is relative formula mass. So remember, X2CO3 equals to RFM, relative formula mass. Apply the RAM. So we have 2x plus carbon is 12. So 12 plus 3 times RAM of oxygen is 16, and try to put the value 138, which is RFM 138, and we try to calculate the RAM of x. The answer is given here. All right, so we move on to the next one. Okay, why carbon 12 is used as standard atom? Carbon 12 is also as an isotope. Carbon 14. What is the function of carbon 14? Is used to determine the age of fossil, ancient artifact, all that. Carbon 12 is used as a standard atom to determine the RAM, RMM, and RFM. Why carbon 12 is used? Because most abundant isotope. This carbon 12 is easy to handle because it exists as solid. Many elements can combine or can react with carbon, and is already used as a reference in spectrometer. All right, we move on to the determining empirical formula of magnesium oxide, and this crucible method, this is known as crucible method. In this method, we can use to determine the empirical formula of magnesium oxide or zinc oxide. The metal should be reactive metal. So what are the reactive metal? Magnesium or zinc are the reactive metal. So magnesium react with oxygen, we will get magnesium oxide, balance the oxygen. So I put 2 here, 2 here to balance oxygen. The magnesium will be 2, so I put 2 here. If let's say in the exam they give zinc, zinc react with oxygen, so we will get zinc oxide. Zinc oxide, how to balance? Put here 2 here, 2 here. And remember, always remember this one, zinc oxide, magnesium oxide. The color is white color powder. Zinc oxide when hot, when hot and when cold. When hot it will be yellow color, when cold it will be white color powder. All right, we check the question. First, they ask us to write chemical equation. So write down the chemical equation. Explain why the magnesium coil need to be cleaned with sandpaper to remove the oxide layer from the surface of magnesium. To remove oxide layer on the magnesium coil. Why the magnesium, the lid must open occasionally or every interval of time to allow the oxygen from the air to enter inside the crucible and to react with magnesium. So this is the answer. Okay, and write down one more question. Okay, why once the magnesium ribbon start to burn, when the magnesium ribbon start to burn, why the lid must kept closed? Why the lid must kept closed? Because when it start to burn, it will produce white color film. This white film is magnesium oxide. We don't want this white film escape into the environment. Why the lid must kept closed when the magnesium ribbon start to burn? To prevent the white film from escaping into the environment. So this is the answer. Please remember. And how do you ensure all magnesium is reacted completely? Always remember, when they ask reacted completely, repeat HCW process. What are the HCW process? The process of heating, cooling, and weighing is repeated until a constant mass of magnesium oxide is obtained. And the table given and the finding is given. All right. So if in this is given to us, they ask another question, state the observation in this experiment. We have total 3 observation. Number 1 is what? White fume. White fume is released. Okay. Number 2, white color powder. White color powder. Powder is formed at the end of the reaction. And next one, okay, third observation, check the crucible. This is during heating process. This is after the experiment. So we can see the mass of crucible and its content increases. So we put here mass of crucible and its content increases at the end of the reaction. From here, we need to find the mass, determine the empirical formula of magnesium oxide. First thing, do the table, find the mass of magnesium. How to find the mass of magnesium? Just cut. Okay, mass of crucible, mass of lead. So I have mass of magnesium 26.4 minus with 224, so we will get 2.4 gram. How to find the mass of oxygen? Mass of crucible cancel, lead cancel, magnesium cancel, so we have oxide. So 28.0 minus with 26.4, we will get 1.6. So how to find the number of mole? Use the formula mass over molar mass. Okay, mass over molar mass. So I use the mass of molar mass, I get 0.1 mole. I got 0.1 mole, I already put unit. Find the ratio 0.1 divide with 0.1 and here 0.1. So the empirical formula will be magnesium oxide MgO. Next, we move on to the chapter empirical form, determining empirical formula of copper 2 oxide. Next, we move on to the to determine the empirical formula of less reactive metal. So here this will be copper 2 oxide. So make sure remember the name of copper 2 oxide, must put the oxidation number. Okay, this copper 2 oxide is a black color powder, and we can use this method, we can use to determine the empirical formula of less reactive metal from its metal oxide, copper 2 oxide, or lead 2 oxide. In this reaction, we need acid and metal to produce hydrogen gas. So the name of the acid, we can use sulfuric acid or hydrochloric acid or nitric acid. The name of the metal, please use active metal like magnesium or zinc. Alright, so in this reaction, so write down the chemical equation. The copper 2 oxide will be reacted with dry hydrogen gas to produce copper and water. Copper and water. So the equation will be like this. Okay, copper 2 oxide reacted with dry hydrogen to produce copper plus copper water molecule. So in name the acid Y and metal X. So I try to name the acid X. I use hydrochloric acid. The metal X will be, we can use magnesium or zinc powder. Write down the chemical equation to produce hydrogen gas. So let's say I'll take hydrochloric acid. Hydrochloric acid reacted with zinc, so we will get here Zn2 positive, so hydrogen ion and chloride ion. During chemical reaction, so we will get H2 hydrogen gas, zinc and chloride join combined together, so we will get ZnCl2, zinc chloride. So balance the equation, we need to balance the chloride here too, so I put 2 in front of hydrochloric acid. So the equation will be like this. So what is the function of anhydrous calcium chloride? If let's say here we have a mixture of hydrogen plus oxygen that enter via an environment or from the air. So when we bring burning wooden splinter, we can hear pop sound. When the mixture of hydrogen air gas and oxygen gas will produce pop sound. So in this apparatus, we have a lot of hydrogen and oxygen. So when we heated up the combustion tube, it can cause explosion. To remove the oxygen gas, so we need anhydrous calcium chloride. The function of anhydrous calcium chloride, don't put to absorb oxygen gas, must put to dry the hydrogen gas. And student must remember at least 2 safety precaution in this experiment. Okay, the safety precaution number 1 will be to the dry hydrogen gas is passed through the combustion tube for few minutes to remove all the air oxygen, because the mixture of hydrogen gas and air or oxygen can cause explosion. The flow of hydrogen gas should be continuous. That's why we use the still funnel. We will add concentrated hydrochloric acid. Okay, is throughout the experiment to ensure air does not enter the combustion tube and mix with the hydrogen gas, and this may cause an explosion. So when the odd product, the odd copper that for produce is odd copper, okay, must be cool in the stream of hydrogen gas. Why? Okay, explain why the odd copper form is cool in the stream of hydrogen gas. This is to ensure the oxygen from the air does not oxidize the odd copper to copper 2 oxide. How do you ensure all copper 2 oxide reacted completely with dry hydrogen gas? So we do what? We repeat this 3 process, HCW process. Repeat the process of heating, cooling and weighing until a constant mass of copper is obtained. Okay, based on the information given, try to do calculation. The calculation already done. Please check the module and try to do revision. All right, so I move on to the next one. Okay, how to interpret an equation qualitatively and quantitatively. If they want qualitatively, they want the name of the reactant used and also name of the product and their physical state. If quantitative means they want in terms of number, how many moles of reactant and moles of product is produced. So look at this question. So here we have sodium react with oxygen. Okay, so to produce sodium oxide. So 4 mole of sodium reacted with 1 mole of oxygen to produce 2 mole of sodium oxide. Qualitative terms. Okay, so the sodium, the reactant used is sodium solid and oxygen gas, and the product is sodium oxide. And quantitative terms, 4 mole of sodium react with 1 mole of oxygen gas to produce 2 mole of sodium oxide. So the answer will be here. So I don't understand. We try to do another one. When A react, give you B plus C. So if let's say I'll take copper 2 oxide reacted and produce copper 2 carbonate reacted and produce copper 2 oxide plus carbon dioxide. How to read this one in terms of quantitative terms? Okay, quantitative term. So 1 mole of copper 2 carbonate. So if let's say A decomposes, please use decompose to produce 1 mole of copper 2 oxide, and 1 mole of carbon dioxide gas is released. So that's how we do quantitative terms. All right, next we go for a calculation. How to find molecular formula when empirical formula is given. When empirical formula is given, open bracket, write down the empirical formula, put n symbol, write down, find the RMM value given here. So from here, apply the RAM into the empirical formula and try to find the answer is given here. The answer is given here. All right, so how to calculate the percentage of nitrogen in ammonium sulfate? Okay, so how to calculate? So the percentage of nitrogen, we take the mass of nitrogen in ammonium sulfate, divide with 1 mole of ammonium sulfate, RMM of ammonium sulfate, times with 100%. So here we try to do this one, so we find the answer is here. We try to check another example, find the percentage of carbon in C2H4. So how to find the percentage of carbon in C2H4? So we take 1 mole of ethene compound contains 2 mole of carbon atom. So 2 times with RAM of carbon, divide with RMM of C2H4, times with 100%. So 2 times with 14, divide with 2 times with 12. Sorry, this one I do again. Sorry. Okay, 2 times with 12, divide with 2 times 12 plus 4 times with 1 times with 100%. Then you take calculator and find the answer. 24 divide with the 24 plus 8, 28 times with 100%, and the answer will be so the answer will be 85.71%. All right. So we move on to the next part. Next chapter, periodic table, chapter 4. Okay, the first thing that student must remember, the physical properties of group 1 metal. So the name of group 1 metal, please remember, is alkali metals. These alkali metals, please remember, LINAC. Okay, lithium, sodium, and potassium. All group 1 metal are good conductor of heat and electricity. They are soft metal, very important. All group 1 metal, okay, are shiny gray color solid. They must place in paraffin oil to avoid contact with water. Okay, transition metal from group 3 until group 12. Okay, from group 3 until group 12, or sometimes they will draw like this. Okay, where is the position of transition metal? The position of transition metal from group 3 until group 12. All right, so all these transition metal, if they are special characteristic of transition metal, they form colored ion or colored compound. They shows different or various oxidation number in their compound. They act catalyst in certain chemical reaction, and they can form complex ion. When catalyst, what is mean by catalyst? Catalyst is a chemical substance added in small quantity to alter, okay, alter the rate of reaction without itself involved in the reaction. So we have few process that student must remember. Haber process, the name of the catalyst used is iron. Contact process, the name of the catalyst used is vanadium 5 oxide. Oswald process, the name of the catalyst used platinum. Okay, hydrogenation process, the name of the catalyst used is nickel. Sometimes the student must remember this one. Hydrochloric acid react with zinc reactive metal. We will get zinc chloride plus hydrogen gas, balance the equation. Or sulfuric acid react with magnesium, we will get magnesium sulfate plus hydrogen gas. This reaction can be speed up by adding catalyst that is known as, what is the name of the catalyst used here, is copper 2 sulfate solution. Or one more, decomposition of hydrogen peroxide. When hydrogen peroxide decomposes, take the oxygen, put here, remove this one, put your water molecule, then erase out to balance here 2 in front here, put 2. Okay, then balance the hydrogen for hydrogen 4. In this reaction, what is the name of the catalyst used is MnO2, manganese 4 oxide. So please remember all this. Okay, next one. We go for question number 4. Why argon exists as inert or chemically stable, or exists as monoatomic gases? Why argon exists as monoatomic gases or chemically stable, or chemically unreactive. This is because their valence electron, carbon has 8 valence electron in the outermost shell or valence shell. Therefore, argon has achieved stable octet electron arrangement. When they ask question number 5, when they ask the position of predict element in the periodic table, so use the small number at the bottom one, try to do electron arrangement 2.8.6 and try to check valence electron. Valence electron 3, 4, 5, 6, 7 must put group 13, group 14, group 15, group 16, group 17. So in this case, it will be group 16. And check the number that present 2.8.6. It has 3 number. It from period 3. So how to answer this one, explain. So the electron arrangement of atom X is 2.6. Atom X has 6 valence electrons. 6 valence electron, therefore it's from group 16. Atom X has 3 shells occupied with electron or 3 shells filled with electrons, therefore it's from period 3. So here is the answer. So we go for next one. When going down the group 1, always remember when going down group 1 alkali metal, the reactivity increases because group 1 metal exists as metal will do what? Metal, it will donate their valence electron to achieve stable octet electron arrangement. Which one can donate electron very fast? That metal will be more reactive. So this is the one more reactive. So how to answer? Explain. Element Y is more reactive than element X. Why? Because the atomic size of Y is bigger than X. The attraction force of nucleus of Y towards its valence electron is weaker. Thus, Y easily lost its valence electron to achieve stable octet electron arrangement. Therefore, Y is more reactive. And the reverse will be halogen. When going down the group 17, halogen, from fluorine, chlorine, bromine, or I take the axis. This group 17 element, always remember they exist as diatomic molecule. When going down the group 17, the reactivity will be decreases. So which one is more reactive? P. So element P is more reactive than element Q. Why? Because the atomic size of P is smaller than Q. The attraction forces of nucleus of P towards the electron become stronger than Q. Thus, P easily attract electrons to achieve stable octet electron arrangement. Okay, next will be period 3 element. Period 3 element, Nancy Margaret always sing pop song called. Alright, when going across the period 3, atomic size keep on decreases. Okay, it keep on decreases. Okay, why is decreases? Because when atomic size it decreases when we going across the period 3. This is because of the positive charges. Here we have positive 11, here we have positive 17 protons in nucleus of chlorides. Therefore, the positive charges in the nucleus increases. This increases the attraction forces of nucleus. As a result, the attraction forces of nucleus towards the electron shell become stronger. Thus, the electron shell are pulled closer to the nucleus, causing the atomic size is decreases. Next, contribution of scientists in development of the periodic table. Dmitry Mendeleev arranged the element according to AM, increasing order of atomic mass. Henry Moseley arranged the element according to PN, increasing order of proton number. So Dmitry Mendeleev arranged the element according to increasing order of atomic mass. Henry Moseley arranged element according to the increasing order of proton number. If in the exam they ask what is the basic principle of arrangement of elements in the periodic table. All the elements in the periodic table are arranged according to what? According to increasing order of proton number. Move on to the next is a chemical bonding, chapter 5, form 4. So under chemical bonding, the first question that student must remember, state the physical properties of ionic compound. Ionic compound example, sodium chloride, magnesium oxide that made up of metal plus non-metal, and the particles that present in ionic compound is ion. So the first physical properties will be all ionic compound has high melting point and boiling point due to the stronger electrostatic forces of attraction that exist between the opposite charge ion. So second one will be second physical properties, all the ionic compound conduct electricity in molten and aqueous state only. And please remember, in solid state they do not conduct electricity because the ions are not able to move freely, and they does not conduct electricity. The ions are fixed at the position. And the third physical properties will be generally all the ionic compound soluble in water but insoluble in organic solvent. Next, we move on to the second question. State the physical properties of covalent compound. Covalent compound exists as molecules. They are made up from non-metal that share their valence electron. All right, so in covalent compound, all the because of the weaker van der Waals force, they have low melting point and boiling point, and they are known as insulator of electricity. They do not conduct electricity in any state because they exist as molecules. There is no freely moving ions to conduct electricity. Usually all the covalent compound dissolve in organic solvent such as benzene, but do not dissolve in water, but must remember except this one, except halogen and acid and also ammonia. These three compound, halogen, acid, hydrochloric acid, sulfuric acid, even though they are made up of covalent compound, but they do dissolve in water. At the same time, they dissolve in organic solvent. All right, so we move on to the next question. Explain why sodium chloride can conduct electricity in aqueous or in molten state but cannot conduct electricity in solid state. Sodium chloride is an ionic compound, so therefore they exist in ions. Okay, they have ion. The in solid state, the ions sodium ion and chloride ion are held by stronger electrostatic forces of attraction in lattice structure. So the ions are fixed at the position and do not move freely. Hence ionic compound in solid state do not conduct electricity, but in aqueous or molten state the ions are able to move freely and can conduct electricity. All right, so we move on to the fourth question. Explain why molten lead to bromide can conduct electricity, whilst naphthalene C10H8 cannot conduct electricity. Lead to bromide exists as ionic compound. They have uh, lead to ion and bromide ion. They have lead to ion and bromide ion in molten state. This ion in molten state able to conduct electricity. Therefore, we can see the ammeter needle deflect. While naphthalene compound exists in molecule state, they made up of covalent compound. They exist as molecules. There is no freely moving ion to conduct electricity. All right, so how to answer this one? Lead to bromide made up of ionic compound, and they exist as ion. In molten state, the lead two ions and bromide ion are able to move freely and conduct electricity. Naphthalene is a covalent compound that made up of covalent molecules. In molten naphthalene, there is no freely moving ion to conduct electricity. Thus, naphthalene does not conduct electricity in solid and liquid state. Alright, we move on to the next one, the formation of ionic compound. The formation of ionic compound occur between metal plus non-metal. When metal combined with non-metal, the type of bonding will be ionic bonding. How they form? By transferring valence electron from metal to non-metal. The type of forces is stronger electrostatic. The type of forces will be stronger electrostatic forces of attraction exist between the ion. So sodium 2.8.1, 2.6 will be oxide. So this one will be donated. Sodium will donate one valence electron and form sodium ion and achieve stable octet electron arrangement. And oxide will receive, it has valence electron 6, it need 2 electron to achieve stable octet electron arrangement. Therefore, oxide will form negative ion or anion, and it will receive 2 electron from 2 sodium atom and achieve stable octet electron arrangement. And the formula of the compound form will be sodium oxide. So we have 2 sodium ion with 2.8 with 2.8 and one oxide ion with 2.8. Both ion achieve stable octet electron arrangement. So how to explain this one in assay form? Sodium atom has electron arrangement of 2.8.1. The sodium atom will donate one valence electron, okay, one valence electron to achieve stable octet electron arrangement 2.8. Thus, a positive ion of sodium ion is formed. Oxide atom has electron arrangement of 2.6. The oxide atom or oxygen atom will receive how many electron? It will receive 2 electron. It need 2 electron. Okay, from how many sodium atom? From 2 sodium atom. From 2 sodium atoms to achieve stable octet electron arrangement, which is 2.8. Thus, a negative ion of 2.2 negative, O2 negative is formed. The sodium ion and oxide ions are attracted together by stronger electrostatic forces of attraction and form ionic bonding or ionic compound with the formula of Na2O. And how to draw the electronic arrangement of the compound? So we have sodium 2 ion, so sodium 2 ion, and we have oxide ion. Both of these ion already achieve stable octet electron arrangement. Alright, so that's how we answer the essay question for the formation of ionic bonding. Next question will be formation of covalent bonding. So covalent bonding occur between non-metal, the formation between non-metal, they will share valence electron. And we have three type of covalent bonding, which is single covalent bonding, double covalent bonding, and triple covalent bonding. So one of the example how to get the formula: carbon 6 and chloride is 17. How to get the formula 2.4? Write down the electron arrangement. 2.8.7 will be electron arrangement of chloride atom. Ask question, how many electron needed to achieve octet by carbon? Carbon need 4 more electron to achieve octet, and chloride need 1 more valence electron or 1 more electron to achieve octet. So use this one and do crossing. So bring the 4 here, 1 will be here. So the formula carbon 1 Cl will be 4. So this is formula for tetrachloromethane. Alright, tetrachloromethane. Alright, so how to draw this one? How to draw the electron arrangement of this compound? So remember, circle this one, just put inside. Put inside the sharing shell, and outside of valence shell of chloride, 7 minus 1. Take the 7 minus 1, we need to put 6. Look at the formula. Formula is given here, so I try to draw here. Carbon will be 1. Carbon, it has 2.4. Carbon 2.4. So first shell 2 electron, second shell leave it empty, and check the formula. Chloride got 4 chloride atoms, so I put 1 chloride atom here, 2 chloride, second, third one, and fourth one. Each chloride atom, chloride, it has 2.8.7. So first shell, second shell, and third shell put inside. So this is first shell, second shell, the valence shell put inside for sharing. First shell, second shell, and the valence shell is here. First shell, second, and third shell. Fill up the first shell and second shell. First shell 2 electron, first shell will be 2 electron, first shell will be 2 electron, 2 electron. Second shell will be 8 electron. Okay, 2.8. Alright, now check this one. Alright, so chloride inside put 1, inside the sharing shell. Chloride inside the sharing shell put 1, chloride inside the sharing shell put 1, put 1, put 1. Okay, outside of valence shell put 6. So outside of valence shell put 6, 1, 2, 3, 4, 5, 6. 1, 2, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Always remember, if chloride contribute 1 electron, carbon should contribute 1 electron. They sharing mutually 1, 1, 1, 1. So this is the electron arrangement for CCl4. Okay, how to answer in essay form? So how to answer? First point, carbon atom has electron arrangement of 2.4. Carbon atom, chloride atom has electron arrangement of 2.8.7. So one carbon atom contribute how many electron for sharing? It will contribute 4 valence electron for to 4 chloride atom, and 4 chloride atom will contribute 1 valence electron each, okay, to carbon atom. And one carbon atom, they shares 4 pairs of valence electron. They share 1 pair, 2 pair, 3 pair, 4 pair. They shares 4 pairs of valence electron with 4 chloride atom and form 4 single covalent bond. And next one, all carbon atom and chloride atom has achieved stable octet electron arrangement. A covalent compound with the formula CCl4 is formed. And how to draw the drawing is here. Alright, we move on to the next one. Very important essay question will be formation of triple covalent bond. Triple covalent bond, remember, always remember, if double covalent bond, we have two example. Number one, oxygen molecule, the formula will be O2. Okay, number two will be carbon dioxide, the carbon dioxide formula CO2. This is for double covalent bond. For triple covalent bond, the only one example will be nitrogen molecule. So how to answer this one? The formation of triple covalent bond can be explained by using nitrogen molecule. We must give example. Look at the question. By using an example, explain the formation of triple covalent bond. Include electron arrangement for the compound. Nitrogen atom. So we check point number 2. Nitrogen atom has electron arrangement of 2.5. Nitrogen atom need 3 more electrons to achieve stable octet electron arrangement. If we check nitrogen 2.5, it need 3 more electrons to achieve stable octet electron arrangement. 2 nitrogen atoms. So we take 2 nitrogen atoms contribute 3 valence electron or 3 electrons each, setiap satu for sharing. 2 nitrogen atom, they will share 3 pairs of valence electron, 3 pairs of valence electron, okay, and form triple covalent bond. Okay, both nitrogen atoms achieve stable octet electron arrangement. A covalent compound with the formula of N2 is formed. Alright, we move on to the next one, dative bonding. Example of dative bonding, please remember, number one is formation in ammonium ion. We can see in ammonium ion. Number two, we can see the formation of dative bonding in hydroxonium ion. So how to draw for hydroxonium ion? So when we take water molecule combined with hydrogen ion, so it will form hydroxonium ion. So water molecule made up of oxygen 8, okay, hydrogen 1, 1. How to draw Lewis structure? So 2.6. So Lewis structure, I take valence electron. So oxide atom has 6 valence electron. 1, 2, 3, 4, 5, 6. And this hydrogen atom, it need 1 more electron to achieve stable octet electron arrangement. That means I divide here. So this hydrogen atom will share a pair of valence electron, form single covalent bond, achieve duplet electron arrangement, and same goes to another hydrogen atom. So this will be water molecule. Okay, always remember hydrogen ion. Hydrogen ion, so do not have electron in the shell, and it need how many electron? It need 2 more electron to achieve stable 2 electron to achieve stable duplet electron arrangement. So what will happen? The lone pair, or we call unshared pair of electron. Oxide atom, it has how many unshared pair of electron? 2 unshared pair of valence electron. Okay, so the one unshared pair of valence electron will be contributed to hydrogen ion okay, in the formation of Datif bonding. So how to draw this one? So we open bracket, close bracket, we write down the formula of water molecule O. So it has two unshared pair of valence electron. So this is bonding pair. So this hydrogen ion will form dative bonding with oxide atom. Thus, it will contribute the charges to the formation of ion. So here we have hydroxonium ion. So we check another example, formation of ammonium ion. So the Lewis structure already given in the module, please go through. So how to answer this question? So first one, ammonia molecule consisting of nitrogen atom that achieve stable octet electron arrangement and three hydrogen atoms that has achieved stable duplet electron arrangement respectively through formation of covalent bonding or single covalent bonding. Okay, nitrogen atom in ammonia molecule has one lone pair. So we can check here, this is the lone pair or unshared pair of electron. Okay, valence electron. Hydrogen ion do not has any electron in the shell and it need two more electron to achieve stable duplet electron arrangement. The one unshared pair of electron of nitrogen atom that not involved in the formation of covalent bonding in ammonia molecule will be shared with hydrogen ion through formation of dative bonding. Thus, ammonium ion with the formula NH4 positive is formed. In ammonium ion, nitrogen atom and all the hydrogen atoms have achieved stable octet and duplet electron arrangement respectively. Alright, so this is the drawing that student must draw. Alright, we move on to the next one, formation of hydrogen bonding. Formation of hydrogen bonding can be seen in water water molecule and also in ammonia molecules or one more hydrogen fluoride molecules and in order to form an hydrogen bonding we must have first thing that we must have what we must have nitrogen atom, we must have more negative atoms should be present in the molecules. More electronegative atoms will be FON phone, okay, or NOF. Remember phone or NOF. Most electronegative will be fluorine atom. And also the most electronegative, the negative atom should have unshare pair of valence electron. Alright, so in the formation of hydrogen bonding, I'm explaining with the example of water molecule. The formation of hydrogen bonding can be explained by using water molecule. Oxygen atom in water molecules is a highly electronegative atoms. So water molecule H2O consisting of two hydrogen atom that share one pair of valence electron each with a highly electronegative oxide atom through formation of covalent bonding. The electron pair that share between the hydrogen atom and oxide atom will be pulled towards the oxide atom because oxide atom is highly electronegative atom. This causes the hydrogen atom become a partial positive. So partial positive. So here we need to put partial positive, while the oxide atom become partial negative because oxide atom is more electronegative atom. Thus, water molecule become a dipole molecule. The attraction forces between hydrogen atom and oxide atom of nearby water molecules form a hydrogen bonding. So this how we draw this one. All right, so this is the explanation for the formation of hydrogen bonding. Next, we move on to the formation of metallic bonding. The formation of metallic bonding occur between metals. So what are the metals that form metallic bonding? Sodium metal, magnesium metal, and aluminium metal. So try to do example of essay question. So here I give one example of essay question for the formation of metallic bonding. Formation of metallic bonding can be explained by using sodium metal. Sodium atom has electron arrangement of 2.1 and exists as solid. Sodium atom in solid state are arranged closely packed and in lattice structure. Sodium atoms can only vibrate and rotate at the fixed position. During vibration and rotation, some of the valence electron of sodium atoms can be delocalized. They will move within the atoms. So the delocalized electrons form sea of electrons and the sodium atom become positively charged ion. The attraction forces between the sea of electron and positively charged ion, sodium ion, form a metallic bonding. All right, so that's how we draw here. So next part we go for this one. State the three factors that affect the metallic bonding. First factor, the number of protons, or the proton number of protons. The more protons, the stronger the metallic bonding. The second one, the number of delocalized electron per atom. The more delocalized electron, the stronger the metallic bonding. And the size of ion. The smaller the size of ion, the stronger the metallic bonding. Try to check question number 12. Magnesium has stronger metallic bonding compared bonding than sodium atom. Okay, why we must use these three factors: first factor, second factor, and third factor in explanation. Thus, it has a high melting point. Okay, more heat is required to overcome the forces of attraction in magnesium atoms than sodium atom. Why? Because the number of protons that present in magnesium atom is higher than in sodium atom. Magnesium atoms more valence electron in the shell compared to sodium atom. Thus, magnesium atoms contains more delocalized valence electron compared to the sodium atom. Magnesium ion is smaller than sodium ion. Why? Because its size is smaller. When size is smaller, it has more positive charges in the nucleus. The attraction forces is very strong, so the electron shell will be pulled closer to the nucleus. Thus, the stronger forces of attraction exist between the magnesium ion and its delocalized valence electron compared in sodium atoms. So, the more heat is required to overcome the metallic bonding forces in magnesium than in sodium. All right, next, please check. Draw the question number 13. Draw the electron arrangement of carbon dioxide. Okay, carbon dioxide is made up of carbon, and oxygen. So this is 2 point carbon. We try to get the formula carbon 6, oxygen 8. So we try to do the electron arrangement 2.4, here 2.6. Try to ask questions. So ask question: how many electron needed by carbon to achieve stable octet electron arrangement? That will be 4. How many electrons needed by oxide atom to achieve stable octet? 2. Then you do crossing, we do crossing, 4, 2. And when both number is even number, simplify as 1 and 2. So the formula carbon dioxide. So how to draw this one? So remember, this is the one we have to put. Okay, we put here, put inside the sharing shell. Inside the sharing cell, outside will be, we take the 6 minus with 2, outside 6 minus 2, we need to put 4. So how to draw? Check the formula carbon, first shell, second shell. First shell, write down the electron arrangement 2. Then we have checked the formula, we have 2 oxide. So I put here 1 oxide will be here, another oxide will be here. It has 2 shell, first shell, valence shell, put inside. Okay, so it has first shell and valence shell we put inside. All right, so check this one. Okay, carbon oxide first shell we have 2 electron. First shell we have 2 electron. So the valence shell put inside. Oxide, the valence shell put inside 2. So oxide, the valence shell put 2. Okay, oxide, the valence shell put 2. Outside we put how much? We put 4. Outside we put 4. So outside 1, 2, 3, 4. Outside we put 4. 1, 2, 3, 4. When carbon oxide contribute 2 electron for sharing, carbon should give 2 also. So carbon will give 2, 1 and 2. Here also same 1 and 2. This is the formation of carbon dioxide molecule. So I already draw here. All right, so next one, what is the function of hydrogen bonding? The function of hydrogen bonding, the paper can stick to the wet finger due to the presence of water molecule. Water molecule form what bonding? Hydrogen bonding between the cellulose in paper and the water molecule on the fingertips. Dry paper or is hard to flip because only weaker van der Waals force exists between the paper and the dry finger. Okay, so we move on to the chapter 7, acid, base and salt. The first question will be, what is mean by strong acid and weak alkali? Strong acid, an acid that ionizes completely in water, producing high concentration of hydrogen ion. So check this word, ionizes completely. And weak alkali, an alkali that ionizes partially in water, producing lower concentration of hydroxide ion. Okay, question number 2. The pH value of glacial Ethernovic acid is 7, but the pH value of dilute Ethernovic acid is 5. Explain why there is a differences in the pH value. When I take Ethernovic acid CH3COOH, then we put glacial. Remember, glacial, no water. Without water, the pH value will be remains neutral. So when we add water, then only ionization will occur, and there is hydrogen ions to show the acidic properties. So only acid only ionizes in the presence of water. Water is very important solvent to ionize the acid. So how to answer this one? Okay, the first point will be water absent in glacial Ethernovic acid. So Ethernovic acid molecule does not ionize without the presence of water. There is no hydrogen ion to show the acidic properties. Okay, so water present in dilute Ethernovic acid. So what will happen? Ethernovic acid will ionize to produce hydrogen ion. The presence of hydrogen ion will cause the aqueous solution of Ethernovic acid shows its acidic properties. Next one, why the pH value of two different acid, hydrochloric acid and ethanoic acid with the same concentration, is totally different? Because this acid is known as strong acid, ethanoic acid is known as weak acid. So how to answer this one? Ethanoic acid is a weak acid. It will ionize partially in water to produce lower concentration of hydrogen ion. Hydrochloric acid is a strong acid. It will ionizes completely in water to produce hydrogen ion with high concentration. When the concentration of hydrogen ion is higher, the pH value is lower, indicate the acid is strong acid. Next, we move on to the neutralization reaction. So this method is known as titration. This method is known as titration. So titration involves neutralization reaction. Once your students see this one, what is the type of reaction? Neutralization. And chemical equation. So here we have sulfuric acid and reacted with potassium hydroxide. So during this neutralization reaction, potassium sulfate salt will present. So when we have a phenolphthalein, so this indicator will turn into pink. During endpoint neutralization point, so the pink solution turns colorless, is the observation. To calculate the molarity of acid or alkali, so here we must need this one, Ma, molarity of acid. This is Va, volume of acid. This is Vb, volume of potassium hydroxide. Mb, we don't know. So we try to use the titration formula, which is MaVa over MbVb equals to Na/Nb. This Na and Nb we have to look from the equation. So from the equation 1 mole, and this one from the equation will be 2 mole. All right, so apply in the formula. So I take this one. So put here 25 will be here. Okay, volume of acid. The 20 will be volume of base. Then the MB I need to find. So I try to put the number of mole from the equation 1 mole and 2 mole and try to get the answer. 0.25 unit will be mole dm negative 3. All right, check the next question. Experiment is repeated by replacing using hydrochloric acid to replace sulfuric acid. Initially they use sulfuric acid, this sulfuric acid with the concentration of 0.1. Okay, so this sulfuric acid, please remember this sulfuric acid is known as diprotic acid. And they replace the experiment by using hydrochloric acid. This hydrochloric acid, please remember, is a monoprotic strong acid. So we need how many here? So here we need one sulfuric acid. Okay, it will ionize to produce two hydrogen ion. These two hydrogen ion will combine with hydroxide ion and form two water molecule. So here I got two hydroxide ion, therefore I need two hydrochloric acid. It will produce one hydrogen ion and one more hydrogen ion to form water molecule. So 1 become 2. 1 become 2, that means we have to times with 2. So the volume of sulfuric acid is twice. Hydrochloric acid is twice the volume of sulfuric acid. So we take the volume of sulfuric acid, which is 25, times with 2, so we will get 50. How to explain your answer? How to explain? Sulfuric acid used in the experiment is diprotic acid, while hydrochloric acid is monoprotic acid. In the same concentration, the volume that we need to predict is hydrochloric acid. The volume of hydrochloric acid needed to neutralize the potassium hydroxide solution is twice or double the volume of sulfuric acid. Must remember. Alright, so please check the application of neutralization process in the daily life. Alright, next, basicity of an acid. What is meant by basicity? Number of ionizable hydrogen ion per molecule of acid. We have three types of basicity. One is monoprotic, diprotic, and triprotic. This basicity can be used for strong acid as well as to weak acid. Alright, so monoprotic acid, it will produce 1 mole of hydrogen ion. So example, hydrochloric, nitric, Ethernovic acid, and Methanolic acid. Please remember, Ethernovic acid, it will ionize the hydrogen ion from the behind. Okay, so diprotic acid, it can produce 2 mole of hydrogen ion. 2 mole of hydrogen ion, carbonic acid and sulfuric acid. Triprotic acid will produce 3 mole of hydrogen ion, phosphoric acid, and is a weak acid. Alright, check how to calculate the pH value. pH value logarithm, negative logarithm, hydrogen, concentration of hydrogen ion. Alright, so POH will be negative logarithm 10 concentration of hydroxide ion. When pH plus POH, we will get 14. And we want to calculate the concentration of hydrogen ion where the pH value is given. Use this formula. Please check all the example of question given and try to do revision. Alright, we move on to the next question. Next subtopic will be salt. What is salt? Salt is basically ionic compound. The salt is an ionic compound, okay, formed from the hydrogen ion from an acid that replaced by any metal ion or replaced by ammonium ion. Alright, so soluble salt. Please remember solubility of salt. First point, potassium ion, sodium ion, ammonium ion, okay, and nitrate ion. Once this ion present combined with any other ion, all this salt is known as soluble salt. Okay, soluble salt. We call K triple N ion. And remember, all chloride ion are soluble, except please remember Persatuan Agama Hindu. Only this metal ion combined with chloride ion, they will form insoluble salt. Alright, so we have Pb lead to chloride, silver chloride, and mercury chloride. Remember the sulfate ion, all soluble, and when they combine with these three metal ion, they will form insoluble. Okay, what are the metal ion? Please remember Butcher Pb. Barium sulfate insoluble, calcium sulfate insoluble, lead to sulfate, and please remember one more ion, which is carbonate ion. Carbonate ion all insoluble. Okay, insoluble, except which one is soluble. Please remember point number 1, K triple N. So I'll take 2 ion 3, K double N. Potassium carbonate soluble, sodium carbonate soluble, ammonium carbonate soluble, the rest insoluble. Okay, for example, copper 2 carbonate insoluble is a green color salt. Okay, and next one, calcium carbonate also insoluble. So please check here. Metal chloride, which one is insoluble? Persatuan Agama Hindu. And remember, all is white color except PbI2, and this one we can use for chloride ion, bromide ion. The PbI2 is yellow color precipitate, the rest will be white color precipitate. Metal sulfate, barium sulfate, Butcher Pb, all insoluble and they will form white color precipitate. Copper 2 carbonate, this is known as copper 2 carbonate, and please remember the color of the salt is green color. Alright, so we move on to the confirmatory test of ion. Please remember brown ring test. Okay, if nitrate ion present, we need to add 3 solution. What are the solution? We add dilute sulfuric acid, concentrated iron to sulfate solution, and we add 3 drops of concentrated sulfuric acid, okay, without shaking the test tube, so we can see a brown ring form at the middle of the solution. So how to answer? Pour 2 cm power 3 of lead to nitrate solution into a test tube. So here I give example lead to nitrate. Add 2 cm power 3 of dilute sulfuric acid, please write in word form, okay, followed by 3 cm power 3 of concentrated iron to sulfate solution into the same test tube. Shake well test tube. No need to, okay, shake well the test tube, tilted the test tube slightly, add 3 drops of concentrated sulfuric acid along the wall of the test tube carefully, then next without shaking. A brown ring will form at the middle of the solution. Confirm the presence of nitrate ion. Next will be sulfate ion. To test the presence of sulfate ion, we need 3 solution. So I take first one, hydrochloric acid. So next one, so magnesium sulfate. Next will be hydrochloric acid. Next will be barium chloride solution. Barium chloride solution. So the barium ion, Butcher Pb, combined with sulfate ion, they will form barium sulfate insoluble salt. Pour 2 cm power 3 of magnesium sulfate solution into a test tube. Add 2 cm power 3 of 1.0 mol -3 of hydrochloric acid followed by barium chloride solution. Shake well the test tube. A white color precipitate form. Ionic equation given. Alright, next one we go for chloride ion. To test the presence of chloride ion, we add the magnesium chloride solution, then followed by nitric acid, then silver nitrate solution. Okay, a white color precipitate will form. Okay, so the answer is given here. Please go through. Next one, zinc ion. Zinc ion is soluble in excess of sodium hydroxide, is soluble in excess of sodium hydroxide and also ammonia. So we take only one, add drop by drop ammonia solution until excess. A white color precipitate that dissolve in excess of ammonia solution will form. Please go through. Lead 2 ion. So when add lead 2 nitrate solution, then we add potassium iodide solution. So the lead 2 ion combine with 2 iodide ion and will form lead 2 iodide precipitate, insoluble precipitate. Next one, check copper 2 ion. Copper 2 ion, we add copper 2 sulfate solution into test tube. We add drop by drop ammonia solution until excess. A blue color precipitate will form, and this blue color precipitate will dissolve in excess of ammonia solution and will form deep blue solution. All right, move on to the next one, ammonium ion. Very important, please remember Nessler. Please remember this reagent, Nessler reagent. When we add Nessler reagent, ammonium ion is always, remember, is a soluble ion. To test, we need a special reagent that is known as Nessler reagent. So we pour 2 cm power 3 of ammonium chloride into a test tube. We add drop by drop Nessler reagent solution by using dropper, shake well, and we will get a brown color precipitate. And iron 2 ion, if we got iron 2 ion, want to test, just put here PXA. Check here 2, so here take 3. PXR3 solution. What is PXR3 solution? So pour 2 cm power 3 of iron 2 sulfate solution into a test tube. Add drop by drop potassium hexacyanoferrate 3 solution by using dropper. Then shake well the test tube. A blue, black or dark blue precipitate will form. Iron 3 ion, KSCN solution. Potassium thiocyanate solution. So we pour 2 cm power 3 of iron 3 chloride solution into a test tube. We add drop by drop potassium thiocyanate solution. Okay, by using dropper, shake well, a red blood coloration will form. All right, please check this one, thermal decomposition of salt. Okay, thermal decomposition of salt, metal carbonate. When metal carbonate heated, we will get metal oxide and carbon dioxide. All metal carbonate will decompose. Please remember, will decompose except potassium carbonate and sodium carbonate. This one do not decompose. Okay, please remember, do not decompose. All right, please remember for objective question, the equation given, please practice. And next one, metal nitrate. When heated, we will get 3 product, and one of the product will be brown color gas. Please remember this one. All right, so we okay. Next, rate of reaction. So under rate of reaction, the definition for rate of reaction for specific reaction. So we check this one. When there's a reaction release gas, so we try to do the formula. So how to measure the rate of reaction? So we find change in total volume of carbon dioxide gas per unit time taken. So how to define the rate of reaction based on the above reaction? So here the answer, change in the total volume of carbon dioxide gas per unit time taken. And student must remember example of slow reaction. Example of slow reaction, first one is fermentation to produce ethanol. Second one is rusting, slow redox reaction. Third one, photosynthesis to produce glucose and oxygen gas. And the next last one is coagulation of latex. All these as a slow rate of reaction. So it has a lower, the rate of reaction will be lower and the time taken will be longer. All right, so next example of fast reaction, number 1 will be neutralization, number 2 combustion, number 3 burning of active metal, Number 4, double decomposition, and the last one is displacement of metal. All these must remember for objective question. So question number 4, what is state in collision theory? The collision theory, according to the collision theory, the reaction to be occur, the particle must collide in correct orientation. This is the first term. Second one, the particle achieve total energy that equals or more than the activation energy. Activation energy symbol EA. So what is mean by activation energy? Minimal. Minimal energy required by reacting by reactants. So we take by reactants to do what? To reacts. Okay, and the last question number 5, state the factor that affect the rate of reaction. We have total 5 factor. First one, size of solid reactant. Second one, concentration of the solution reactant. And third one, temperature. Fourth one will be presence and amount of catalyst. And the last one is pressure. So under size of reactant, the reason that we should use is total surface area. Concentration will be number of particles per unit volume. All right, so temperature will be kinetic energy of reacting particles. Catalyst will be EA, or activation energy will be lowered if catalyst is present. Pressure will be same like concentration, which is number of particles per unit volume. Right, so these are the factor and reason for the factor. And we go for question number 6. Okay, we need to compare the two set of reaction. First one here, if we check, hydrochloric acid is known as what we call monoprotic acid, and the concentration given 1.0. Then second one is sulfuric acid. Sulfuric acid is known as diprotic acid. So here we have 1 mole of hydrogen ion, here we have 2 mole of hydrogen ion. Therefore the number of hydrogen ion per unit volume is higher. Therefore this reaction, the factor that involved in these two set is concentration. So based on collision theory, how to explain this factor? The first one, hydrochloric acid used in set 1 is monoprotic acid, while sulfuric acid used in set 2 is diprotic acid. The number of hydrogen ions per unit volume in set 2 is higher because we use sulfuric acid, higher than in set 1. The frequency of collision between particles. If student want to mention the particles, can. If don't want to mention the particles, just put between particles increases in set 2. The frequency of effective collision between particles also increases in set 2. Thus, the rate of reaction of set 2 is higher than the rate of reaction in set 1. So we go for second question number 7. So in this reaction, so we have 1.0 mole DM-3 of hydrochloric acid reacted with zinc powder. So here we have two reactant, A plus B. So at this set 2, we have A is hydrochloric acid, B is zinc. They add C. So once they add C, please remember this C is catalyst. So in this reaction, acid plus reactive metal, we will get a salt plus hydrogen gas. In this reaction, the name of the catalyst used is copper 2 sulfate solution. We can use copper 2 sulfate solution as a catalyst. So question only factor that involved here is catalyst present in set 2 while absent in set 1. So catalyst, so how to answer based on collision theory? Catalyst copper 2 sulfate solution present in set 2 while absent in set 1. The activation energy of reacting particles in set 2 is higher than in set 1. The frequency of effective collision, if catalyst, no need to mention frequency of collision, just go through with frequency of effective collision between particles increases in set 2 than in set 1. Thus the rate of reaction of set 2 is higher than set 1. If let's say they ask us to draw sketch the curve on the same axis for this set. So what we do here in this set, we have zinc reacted with hydrochloric acid. So hydrochloric acid, we will get zinc chloride plus hydrogen gas balance. I put 2 here. So in this reaction, we will measure the rate of reaction by collecting the volume of hydrogen gas. So here we put volume of hydrogen gas, which is Cm power 3, and axis X will be time, unit can be second. So which are let's say the volume of these two set is same. So here which one, the graph will be steeper, here will be steeper, here will be less steeper. So what we draw set 2. We try to sketch for set 2. Set 2 will be set 2, the rate of reaction will be higher. Okay, this is set 2, and we try to draw for set 1. The set 1 will be here. So that's how we sketch the curve of set 1 and set 2 in the same axis. All right, we go for next one. State the characteristic of catalyst. The catalyst is a chemical substance used to alter the rate of reaction without itself involved in the reaction. So catalyst used in small quantity can be reused again. Catalyst does not affect the quantity of reactant or product, does not undergo chemical changes, but may undergo physical changes. Before the experiment, maybe it's in the granules, then maybe after that it will change into powder form. That is known as physical changes. Okay, catalyst is used to alter the rate of reaction, speed up or slow down the rate of reaction, okay, or to increase the rate of reaction. The reaction of catalyst is specific. Only specific catalyst is used in a particular chemical reaction. All these must remember. All right, we go for question number 9. Okay, this is K-part question. Explain why the small pieces of meat cook faster than the bigger size of meat. Smaller piece of meat is as larger total surface area exposed to hot cooking oil compared to the larger piece of uncut meat. So more heat energy can be absorbed in shorter time. Hence, the smaller pieces of meat cook faster than the bigger pieces of meat. All right. So we go for next one. Question number 10. Why food cooker faster in pressure cooker? So water vapor is compressed in pressure cooker. So the compression increase the boiling point of water to become more than 100 degrees Celsius. So what happened? The food particles gain more kinetic energy, hence they cook quickly. So right. Okay, we go for question number 11. Explain why small pieces of charcoal burns faster than bigger pieces of charcoal. Smaller pieces of charcoal are easy to ignite because it has larger total surface area exposed to oxygen. Therefore, smaller piece of charcoal can burn quickly and release more heat to the food. The food can cook faster because more heat is absorbed per second. All right, we go for next one. Very important for SPM. All right, so please focus 2021. Okay, explain why food stored in refrigerator lasts longer than the food stored in the kitchen cabinet. The temperature inside the refrigerator is lower than the in the kitchen cabinet. At lower temperature, bacteria become not active. Thus, the growth of bacteria is slower in cold temperature, and bacteria produce less or lower toxic. So this causes what? The rate of decomposition of food become lower. Hence, the rate of food decay to turn bad is slower. So this is the answer that student must remember. We move on to the next question. Okay, reaction, catalyzed reaction, decomposition of hydrogen peroxide. We need catalyst here. One reaction with catalyst. If catalyst needed is mangan 4 oxide. Mangan 4 oxide. If let's say this set EA, label EA with the activation energy, and EA slash without activation energy. So that means here we have catalyst. Okay, here without catalyst. So try to draw energy level diagram and state the position of EA from reactant to the until the puncak gunung here. So this will be the activation energy without catalyst. Then once catalyst present, it will lower the activation energy of the reaction. So this is the activation energy. How to get the activation energy? So here I label this is reaction without catalyst. So for reaction with catalyst, take dot 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 until end here and try to get the EA slash. Then how to explain the rate of this reaction is exothermic reaction, because the energy content of reactant is higher than the energy content of product. It is released to surrounding during decomposition of hydrogen peroxide. The energy content of reactant, which is hydrogen peroxide, is higher than the energy content of the product. The presence of catalyst provide alternative pathway which is lower with lower activation energy. The number of colliding particles which are able to overcome the lower activation energy increases. The frequency of effective collision between hydrogen peroxide molecule increases. All right, please write down in word form. Hydrogen peroxide molecules increases. Thus, the rate of reaction for the reaction with presence of catalyst become higher. So once students write like this, we'll get full mark. Okay, we go for next reaction. Okay, this is something like experiment. We have two factor in one question. So if we check here the first experiment and second experiment, here they use granule, here they use powder. So state the factor that involved between experiment 1 and experiment 2. The factor is size of reactant, and we check factor experiment 2 and experiment 3. Experiment 2, they use zinc powder and hydrochloric acid. Here also zinc powder, hydrochloric acid, the concentration same, but they add additional copper 2 sulfate. So we have copper 2 sulfate here. So this will be catalyst factor. We can check your copper 2 sulfate solution. That means in experiment 3, they use zinc plus with hydrochloric acid, and they add copper to sulfate solution. This will be catalyst. So experiment 2 and 3 will be catalyst. What is mean by rate of reaction? In this reaction, try to do the equation. I try to do the equation here. Zinc react with hydrochloric acid. So we will get zinc chloride plus hydrogen gas. Balance I put 2 here. Alright, I put 2 in front of this. Okay, I put 2 in front of hydrochloric acid to balance the chloride. So once we have hydrogen gas, so we will collect the total volume of hydrogen gas per unit time. So the definition will be changed in the total volume of hydrogen gas per unit time taken. Alright, so we move on to the next question. Okay, how to calculate average rate of reaction? Average rate of reaction can be calculated by using formula. Average rate of reaction, total change in the total volume of hydrogen gas per unit time taken. Where is the total volume of hydrogen gas? If we check here, the time taken to collect 40 cm power 3 of hydrogen gas, the time taken for experiment 1 is 90 seconds. So we find the answer like this. Experiment 2, 40 divided with 55, the time is 55. Experiment 3, 40 divided with 30, 30 is here. Alright, so next we move on to the next question. Based on collision theory, compare the rate of reaction of experiment 1, experiment 2. Rate of reaction for experiment 1 involved with size of reactant. So how to explain? The size of zinc used in experiment 2 is smaller than in experiment 1. So when size of zinc used in experiment 2 is smaller, larger total surface area of zinc in experiment 2 exposed to reaction than in experiment 1. The frequency of collision between particles in experiment 2 increases. Okay, increases than in experiment 1. The frequency of effective collision between particles in experiment 2 also increases than experiment 1. Hence, the rate of reaction of experiment 2 is higher. So we check for next one, the presence of catalyst. Between experiment 2 and experiment 3 will be presence of catalyst. Catalyst copper 2 sulfate solution present in experiment 3. So we can check here it present in experiment 3. So how to answer this one? So first point, catalyst copper 2 sulfate solution present in experiment 3 while absent in experiment 2. The activation energy in experiment 3 is lower than in experiment 2. The frequency of effective collision in experiment 3 is higher than experiment 2. Thus, the rate of reaction of experiment 3 is higher than experiment 2. Alright, next we move on to the graph, how to draw the graph, how to find the average rate of reaction and instantaneous rate of reaction. Please check this one. Marble, what is the chemical formula for marble? Is a calcium carbonate. Please remember, it's a calcium carbonate. Okay, so CaCO3. So we check next one. Alright, what is mean by rate of reaction in this reaction? So we need to find the rate of reaction, volume of carbon dioxide gas divided with time. So to change in total volume of carbon dioxide per unit time taken. So when we have carbon dioxide, we take this formula. Okay, how to find the rate of average rate of reaction in the first 90 second. In the first 90 second from 0 until 90 second. That means we do what? We take the 62 minus with this one 0.00 divide with 90 minus with 0. So answer is here. In the 120 second, 120 second will be 2 minutes. Where is 120 second? So 120 second is here. So this will be T2. 2 minutes. So by we do what in the 120 second, that means we have to minus 1 T1. So we check these two. Alright, we check these two. So how to find the answer? We take 67.0 minus with 48, 48.5 divide with 120, 120 minus 60, then we find the answer. Okay, overall rate of reaction when the volume starts to stop. At what time the volume become constant? So here is the volume become constant. After this one, the volume becomes 70. So maximum volume collected in this experiment is 70 cm power 3. So here is the time 150. So we do what? 70 divide with 150 volume, maximum volume divide with the time. Okay, draw the graph of volume of carbon dioxide against time. Already draw for you all. So please check volume, title, temperature, and the title axis X must have. So we use the scale, we try to draw from here. Okay, we need to find the average rate of reaction. Here they didn't put average. When there is no average word, please remember this is known as instantaneous rate of reaction at specific time 90 seconds. So we do dotted at 90 seconds. We try to find the gradient of tangent. Okay, once we find the gradient of tangent, try to get a coordinate, sharp coordinate, try to find y2 x2 coordinate, and here try to find the coordinate. Okay, try to find the coordinate y1 x1. All right, so once we find this one, so how to find the rate of reaction specifically at 90 second, y2 minus y1 divide with x2 minus x1. Please practice by referring this example. All right, so we go for move on to the next chapter, form 4, last chapter, manufacture of substance in industry. The first thing the student must remember, alloy. What is mean by alloy? Alloy is a mixture of two or more elements with with certain fixed composition in which the major element is a metal, or we can use this definition. What is the purpose of alloy? Alloying is used to improve the appearance of an object, increase the hardness and strength of an object or metal, prevent corrosion of metal. Okay, so here we have a few alloy. Just now I already mentioned about bronze, brass, steel, and stainless steel. So now we go for a few more. Duralumin. Duralumin main composition will be aluminium, copper, mangan. Is used to make a aircraft body, okay, bullet train body, racing bicycle frame. Magnesium. Magnesium is used to make car sport rim, tripod for the photography. Cupronickel is used to make coins. Pewter contain tin, antimony, and copper is used to make souvenirs, trophy, and ornaments. Okay, ornaments. Okay, please remember all these. Okay, we go for next one. This experiment is very important to determine the hardness of pure copper metal and also bronze. All right, bronze is made up of alloy. Please remember bronze is copper. Once we have Zn here, please remember put Sn. All right, the size of atom, this is bigger and this is smaller. Okay, smaller atom. All right, so and this is a lot. Okay, so how to draw for bronze block is here. All right, for pure copper block is here. So please check. Okay, what type of particles present in copper block? That will be atom. State 3 weakness of copper block. First one will be soft. This is known as pure metal. This pure metal is malleable, ductile. Why? Because ductile, they are malleable, they have low resistance toward corrosion. So if they ask you to draw, please draw like this. Always remember tin bigger, copper is smaller, and copper exists as a lot. So we try to draw for steel. Steel made up of iron plus carbon. All right, carbon is a smaller atom, iron is a bigger atom. So how to draw for this one? And iron a lot. So I'll try to draw here. So how to draw? So iron a lot. So I put iron like this. All right. So we draw the atom of iron. So copper carbon is smaller. So I put here. So this is another drawing for steel. All right. Please practice and please remember. After that label, this is iron or ferrum atoms, and this atom is known as carbon atoms. All right. So this is the drawing for steel. All right. For bronze should be like this. All right. Okay. State observation when the weight is dropped onto the copper block and bronze block, and state the inference. So the diameter of dent form. The diameter of dent form in copper block is bigger. This is copper, pure copper block. Okay, the diameter of dent form on bronze block is smaller. This is bronze block. All right, so here is the answer. Okay, the diameter of dent form on bronze block is smaller than in copper block. Okay, inference, bronze is harder than copper block. Bronze is harder than copper block. All right, so explain why bronze is harder than copper block. The copper block, so I put here copper block. Copper block is made up of, okay, same size of copper atoms which are arranged in order and closely packed. The layer of copper atoms can slide easily if force is applied. Now we go for bronze block. In bronze block, made up of copper atom and tin atoms of different size. We can see here the size is totally different. All right, so it's different sizes. Then the presence of tin atom disrupt the orderly arrangement of copper atoms in bronze block. This reduces the layer of copper atoms from sliding over one another easily. So we will get full marks. Please study, please do more question. All right, we go for last part. Next one, question number 5. What is the raw material used to make glass? Okay, the raw material used to make glass is silicon dioxide or silica. Okay, we have few example of only soda lime glass. Okay, the properties, it has lower melting point, it has it has high thermal expansion coefficient. So it's used to make bottle, window pane, mirror, all that. All right, please remember. Lead glass has lowest melting point, it has high refractive index, it also has high reflection index, crack easily as very high thermal expansion coefficient. All right, it's used to make a decorative glass. All right, next one, borosilicate glass can withstand high temperature. It's a very high melting point, can withstand high temperature. It has low thermal expansion coefficient. It's used to make laboratory glassware. Please remember, get laboratory glassware. We have two glass, which is borosilicate and fused glass. All right, so we go for fused glass. Fused glass is made up of silicon dioxide only. It has very high melting point. It has zero thermal expansion coefficient. Does not expand or contract much, and there is a large when there is a large change in the temperature. Is used to make optical lenses, laboratory glassware, telescope or microscope eyepiece. All right, we go for our next one. Okay, ceramic. We have traditional ceramic and modern advanced ceramic. So traditional ceramic is here. Advanced I already discussed in the uses, so please check the notes. All right, so the traditional ceramic is made up of three substances: clay, silicate, and kaolin. All right, what are the properties of traditional medicine in ceramic? Sorry, traditional ceramic inert towards chemicals, hard and strong. That's why if inert towards chemicals, we use to make dental, crown, jug, all that. All right, hard and strong is used to make tiles, brick, concrete, all that. Do not conduct electricity is used to make a fuse, okay, that used in a national grid network system. Okay, it's also high melting point. So it's used to make a crucible, clay pot, all that. All right, please remember. The last part of chapter 8 will be composite material. Composite material, please remember, superconductor is made up of yttrium carbonate, okay, copper 2 carbonate, barium carbonate, and oxygen. It conducts electricity with zero resistance at temperature of negative 180 degrees Celsius. Is used in a wiring system in bullet train, MRI. All right, next one, glass. Photochromic glass is made up of glass, silver chloride, or silver bromide. Okay, it's transparent, absorb UV light, and it will turn darker according to UV light intensity. It's used to make building glass window tinted. Even car window tinted also can, sunglasses also can. It will darken during daytime and become brighter during nighttime. Okay, reinforced concrete is used to make high rising building, tallest building, bridge, dams, all that. It has high compression strength, and it has high stretching strength. Rusting of steel is prevented because it's not exposed to water and oxygen. So these are the complete revision for Form 4. I will meet up you guys in a second slot for revision for Form 5 chapter. So study smart. Okay, I wish good luck. I wish you all good luck. So we will meet up in next slot. Take care.